Just going to recap some of the big ideas that we covered in Module 6. So we started off being able to classify polynomials and a lot of vocabulary. So in this one, given this polynomial, let's put it in standard form first. So highest exponent comes first, then the term with the next highest, and so on from greatest to least. So that's in standard form. Remember, the name is classifying it by the degree and number of terms. So it's a fourth degree, so this is a quartic. And it has 1, 2, 3, 4, and if it's 4 or more terms, we just call it a polynomial. All right, so it's a quartic polynomial. The leading coefficient, now that it's in standard form, is 4. The degree is also 4. The coefficients, I've already accounted for the leading coefficient, so let's just list the other two. It's 3 and -2. 6 is without a variable, that is our constant. Okay, then we did some operations with polynomials. So let's do long division here, but you also want to be sure you know how to add, subtract, and multiply. I'm going to do long division because we do a lot of synthetic when we are finding zeros, so we're going to practice long division. Also, I can't really use synthetic here because my coefficient on my divisor is not 1. So long division, set up the divisor, dividend under the box, 8x to the 4th plus 6x squared minus 2x plus 4. All right. What do I have to multiply 2x by to equal 8x to the 4th? I have to multiply it by 4x to the 3rd. So come through and multiply 4x to the 3rd times 2x. 4x to the 3rd times 1. All right, and when we draw the line, we change the sign so they're both negative. Okay, cancels. Can't combine those because they're not like terms, so I'm just going to write them next to each other in standard form and bring down the rest. Okay, and repeat. 2 times what equals -4x cubed? That's going to be -2x squared. Come through, multiply, get -4x cubed and -2x squared. Draw the line, change the signs. Cancels. 8x squared minus 2x plus 4, bringing down those last two terms. 2x times what equals 8x squared? That would be positive 4x. So 4x times 2x, 8x squared. 4x times 1 is 4x. Draw the line, change the sign. -6x plus 4. 2x times what equals -6x? That's -3. -3 times 2x is -6x. -3 times 1, -3. Draw the line, change the signs. 4 plus 3 is 7. 2x times nothing will give me 7, so this is my remainder. So we write our answer as 4x cubed. I'm just writing out what's on top here. Minus 2x squared plus 4x minus 3 plus our remainder of 7 over the divisor, 2x plus 1. All right, okay, missing factors. Here's where I can use synthetic division. So if x minus 4 is a factor, that means positive 4 is the 0. So we have 1x cubed, -5x squared, -2, 24. Okay, 4 times 1 is 4, add. And we should get 0 here if it's in fact a factor. So my remaining quadratic is x squared minus x minus 6. So can I factor this? Numbers that multiply to be -6 that add up to be -1, -3, and +2. So those are my missing factors. X minus 3 and x plus 2. All right, remainder theorem. This is also using synthetic division. Finding f of 3, so that's what I'm going to put in my box is 3. And whatever I get for my remainder, that's what f of 3 equals. So I'm going to do synthetic division just like I normally do. Oh, I'm missing an x cubed, so I'm going to put a 0. Okay, so we bring down our 2, add, 3 times 47 is what? 120, 141, I think. And add 142. So that last number we get is our remainder. So f of 3 is 142. All right, then another part of this unit that was really big for us was being able to find all the zeros. So if you can factor, do that. Otherwise, you want to graph, find the nice zeros, and then divide them out to get a remaining quadratic that you can solve using the quadratic formula, or perhaps the square root property. Be sure you're accounting for all the zeros. Remember, you can have repeated roots, you can have imaginary or irrational, like square root of 2. And remember, imaginary and irrational roots as radicals, they always come in their conjugate pairs, okay? So we need to, in this one, have 6 different roots. Well, right away, I notice they all have a GCF of x to the third, so I know I can take that out, okay? So I have x to the third minus 3x squared minus 17x plus 3. So why is that helpful? Well, if I set this part equal to 0, x cubed equals 0, I get x equals 0 with a multiplicity of 3. This is occurring 3 times. So that takes care of 3 of my 6 roots, okay? So I need to get 3 more from here, okay? So I'm probably going to graph this one. It doesn't look like it's going to factor nicely. 17 is kind of throwing a wrench in that, so we can graph. So I'm going to graph my original function here. X to the 6th minus 3x to the 5th minus 17x to the 4th plus 3x to the 3rd. All right, so I should see, right, it crossing at 0 because we know 0 is a root and it has a multiplicity of 3. Okay, and we should have 3 other roots. So this one's not quite a 0. If you notice, the y value here is not 0, so we can zoom in even further. That's the really nice part about Desmos, is we can zoom in nice and big. So it is going above the x-axis there, so that's still accounting for 0 being the 0. None of these other places are 0, so it's gradually going above the x-axis, and then it comes back right here. So that's not a nice 0, so I can't divide that one out. This one looks like a nice 0, -3. Okay, so it doesn't look like our other ones are going to be nice, right? Those are not very nice zeros. So we're going to divide out the -3. And we already have 0 as well. So I'm going to, 0's kind of already been taken care of here, so I'm going to divide the 3 out of here, okay? Sorry, -3. So from the graph, we add x equals -3. So we're going to divide that out of this remaining one because we already took out the zeros essentially. So we have -3. We have 1x cubed, -3x squared, -17, and 3. Okay. Multiply. And we do, in fact, get the remainder of 0 like we should. So that was our 3rd degree, right? That was this one. Divided out -3, so this is a quadratic left. So we have 1x squared minus 6x plus 1. I'm going to use the quadratic to solve this one. So we have -b, so +6, minus 4 times a times c, all over 2 times a. Okay, under the quadratic, I get 36 minus 4, which is 32. So I get 6 plus or minus the square root of 32 over 2. 32, I can pull out 16, right? So, sorry, not pull out a 16. It's comprised of the perfect square 16, so I can pull out a 4. So I have 6 plus or minus 4 root 2 over 2. I can take a 2 out of all of those, so I would, final answer, I'm just going to list them all here. Zeros, we have 0, which is multiplicity of 3. We had -3, that just crossed once, so multiplicity of 1. And then we have this guy, which I'm going to reduce. We have 3 plus or minus 2 root 2. And each of those has a multiplicity of 1. All right. And there again, I see the conjugate pair, the plus and minus. All right. Given some information, can we write the equation of the polynomial? Okay, so it has to be degree 4, which means I need 4 zeros. They give me 3 of them here, but remember, if it's imaginary, I also need its conjugate. So in this case, negative 3i. Okay, so in factored form, we have some leading coefficient that we don't know, which I'm going to use this in a second to find that out. In factored form, negative 2 is going to be x plus 2, x minus 1, x plus 3i, and x minus 3i. Now remember, I'm okay with you leaving it in factored form, but we want to distribute enough to where I don't have i's or radicals. So I just need to get these guys, difference of squares. This is what I am going to end up with. 3i squared is 9i squared, which is negative 9. X squared minus negative 9 is x squared plus 9. So here's what we got for our polynomial. Sorry, hard to write backwards here. All right, so now what we're going to do is we need this point to exist. So when I put in 0, I need the outcome to be 18. So I'm going to do that and solve for what the a value must be. So I'm putting in zeros in for all these x's. So 0 plus 2 is 2. 0 minus 1, negative 1. 0 squared is 0, plus 9 is 9. So I get 18 equals negative 18a. So a then is negative 1. So our final equation for this polynomial, leading coefficient negative 1. And then I'm going to leave it in factored form. There. All right, a couple more here, guys. Our last sections were about analyzing the graphs. So here is the equation for this graph, okay? It has a third degree, so that means the maximum number of turns it can have is 2. End behavior, remember the notation, we want to say as x approaches infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? So on the right side, our graph is going down, and on the left side, our graph is going up. All right, so now our local min and max, that's where I have a hill or a valley, right? So minimum is a hill. We want to give the y coordinate, so negative 4.262. Max is our hill. Y value there is 1.225. Interval of increase. Remember, this is where is it rising from left to right, and we just look at the x values. So it's rising here between the min and the max. So the x value there is negative 0.549. And it continues until x is 1.215. Decrease. It's decreasing from the left until it hits the min and from the max onward. So negative infinity up to this x value. And this x value up to positive infinity. It's decreasing again. All right, this one is asking us to sketch a graph and then identify the domain and range. So we know that when it's in factor form, these are the zeros. So I know I have a 0 at negative 3 and at negative 1. So I'm going to put points there. Negative 3, negative 1. All right, my leading coefficient is negative, so that means my ends are going to be opposite. Excuse me. My right side is going to be going down. So I know it's going to look like this on the right. My degree. So in factored form, we actually need to add the exponents to figure out the degree. Or we can distribute and do it that way, but that's a lot longer. So in fully distributed form, it's just what's the highest exponent. but if it's in factor form, we add the exponent. So 2 plus 2 is 4. So this has a degree of 4, which means the ends are going the same direction, right? It's even, but the negative means it's going down. Okay, so my ends are going to do this. Okay, we could plug in 0 here to get the y-intercept. Actually, I'm going to do that real quick. F of 0, negative 2 times 3 times 1. So negative 6 looks like is our y-intercept. All right, so it's going to come down here. So now we need what happens in the middle. Well, this can have a max of 3 turns, okay? And the multiplicity. So remember, because it's even, it's going to bounce at that 0. So it's going to touch negative 3 and bounce, but it's got to come back up to hit the negative 1. And it's going to bounce again and come back down. So there's this little kind of like local min in between there. Okay, we don't know exactly what value that is without plugging in some x's, but I know the end behavior, I know the zeros, I know the y-intercept, and I know what's happening at each of the roots. Is it crossing or bouncing? And that is enough to satisfy this graph. All right, guys, that is it for the review notes.